Hello, I'm Dr. Tahir. This video tutorial is solution to problem 4 by 19 from Engineering Mechanics Statics 9th edition by J.L. Meriam, L.J. Craig, and Jan Bolton. Statement of the problem is determine the forces in member A, B, C, G, and D, E of the loaded truss. So forces in member A, B, then C, G, and then D, E are required. So the method which I'm going to use to solve this problem is method of joints. So steps to find member forces using method of joints are: the first is select a joint with at least one known force and two or less than two unknowns. So there are five forces or loads acting at joint A. So one load is acting and joint A is a support. So it is a pin support. So it has two reactions. At joint A, there are four unknowns. At B, there are four unknown. At C, there are three unknown. At D, there are four unknown. And at E is a roller sport. So roller sport that has one unknown reaction. So at E, there are three unknown. So no joint satisfy the condition. So then need to find sport reaction first. So this truss is geometrically symmetrical truss because a line of symmetry can be drawn through CG, and both sides of the truss they are mirror image of each other. And again, the truss is symmetrically loaded because one load is acting on the line of symmetry and other loads are applied in mirrored pairs on the line like as B and D and A and E. So the loads are equal and they are being applied at symmetrical location. So this structure is geometrically symmetrical and then is loaded symmetrically, but the supports are not symmetrical. So the supports here they are not symmetrical. So then because supports are not symmetrical, so support for symmetrical supports they must be either both horizontal or vertical, and they should be on either horizontal base or a vertical base. So the supports are not arranged symmetrically. So it looks like it is a symmetrical truss, but it is not symmetrical truss. So then we have to find reactions using standard method. Or otherwise, because the vertical loads are symmetrical, so the reaction at both port in the vertical direction, so they are equal and they are half of that vertical load because both of the supports are at angle of 45 to the horizontal. So then uh, horizontal loads and vertical loads they are equal. They are equal. So both horizontal load at A and E they are equal. Both vertical load at A and E are equal. So these are steps to find reactions in a truss. Draw a free body diagram of entire truss and then pin support that has two reaction in horizontal and vertical. It doesn't make any difference. So whatever is the direct orientation of pin support, horizontal, vertical, or at an angle, so it always have two reactions in horizontal and vertical. And a roller support has one reaction R that is a normal to the surface, so that is a perpendicular to that support. And then need to apply conditions of equilibrium and choosing a moment point which has the most unknown. And then it is possible to assume any suitable direction of the reaction. And then once the reactions are calculated, so then the sign they are going to tell about that direction. So a positive value confirm that assumed direction and a negative value mean actual direction is opposite. Probability diagram of entire truss is drawn at A. Two reactions are there, AX and AY. I have assumed both as in positive X and positive Y direction. Reaction at E is RE, which is perpendicular to the support. So I am going to apply conditions of equilibrium to find reaction. So I'm going to take moment about point E. So to find moment about point E, AX is going to pass through E. So it doesn't have any moment. RE is also passing through E, no moment. And AY, so AY is going to produce a moment in clockwise direction. AY times by the total distance. So that D is the distance for each segment. So AY times by 4D. And then L by 2 is going to produce moment in anti-clockwise direction. Load at B is going to produce moment in anti-clockwise direction, and L2 is going to pass through port E, so it is not going to produce any moment. So, and then moment due to load at D, C, B, and A, so they are all in anti-clockwise direction, so they are all positive, and moment due to AY is negative. So then I can write that as minus AY times 4D, then L times D, then at point C, L times 2D, at point B, L times 3D, and at point A is L by 2 times 4D. So then after simplifying, AY is calculated as. Next, I'm going to apply sigma Fy equal to 0. So to find sigma Fy, or to apply sigma Fy equal to 0, I need to resolve Re into components. Now here, uh, all triangles are all are isosceles triangles. So two sides are same, and uh, triangles are right angle triangles. So the all angles will be 45 degrees. So the RE then makes an angle 45 with horizontal and with vertical as well. So RE is resolved into two components, EX and EY. So then I can apply sigma Fy equal to 0 as AY is in upward direction, RE resolved into a EY that is also acting in upward direction, and then the total load is 4L that is going to act vertically downward. So AY is already calculated at 2L. So by substituting here, EY comes as plus 2L. Now RE can be written in terms of given loads L as EY is equal to RE sine 45. So EY is known as 2L. So then by rearranging, RE is EY over sine 45. So EY is 2L. So then RE comes as 2 root 2L. Using RE as 2 root 2L, I can find EX, which is RE cosine 45. So EX comes as 2L. So now I have one horizontal reaction EX. So then I can find AX using sigma fx equal to 0. Now sigma fx equal to 0, AX is positive, EX is negative. So AX minus EX is equal to 0. So AX is equal to EX. Then AX is again plus 2L. So now all reaction AY is positive, EY is positive, then RE is also positive, EX is also positive, and then AX is equal to 2L. So all reactions are positive. So then interpretation of the sign, a positive value confirm assumed direction and a negative value means actual direction is opposite. So because all answers are positive, it means that assumed directions are correct. AY is 2L upward, EY is 2L upward, AX is 2L towards right, EX is 2L towards left. So now all support reactions are calculated. So now I'm going to select joint A because at joint A there are three known and then two unknown. And again, ABH is an equilateral triangle. So one angle is 90 degree, the other two angles they will be 45 degree. So then next step is to isolate the joint, draw a free body diagram, and then assume all member forces in tension, and then to apply equilibrium condition by resolving inclined member into components. Body diagram of joint A is drawn. So AB and AH, so they are assumed in tension, and there are three. So one load, and then there are two reactions. So they are shown here, and then angle of AH with horizontal is 45 degrees. So now that's joint A, and there is only one inclined member AH. So AH is resolved into its component AH towards positive x-axis and then AHY towards negative y-axis. So then there is only one unknown in vertical direction. So I'll apply sigma Fy equal to 0 first, and applying sigma Fy equal to 0 first. So AHY is downward negative, then AY reaction is acting vertically upward and load is half L acting vertically downward. So AY is equal to 1.5 L. So AHY using angle 45. So AHY is AH sine 45. So then AH comes as plus root 3 over 2L. So next, by applying sigma x equal to 0, so AB is positive, AHX is positive, and then AX is also positive. So it can be written as AB plus AHX plus AX equal to 0. So AB is minus AHX minus AX. So AHX is simply AH cosine 45. So AH is calculated as plus 3 root over 2. So by substituting the values, AB is minus 3.5 L, because the answer of AB is negative. So then the interpretation of the signs of unknown member as a positive value indicate tension and a negative value indicate compression. Because AB is negative, so AB is in compression. Now that's the answer for from joint A. AB is 3.5 L in compression. So the next I need to find DE, and for that I'm going to isolate joint E and going to draw a free body diagram of joint E. So that's a free body diagram of joint E. So DE and EF are assumed in tension, and the angle of EF with horizontal is 45, and load is half L, and the two reaction EX and EY both are equal to 2L. So at joint E, EF is on inclined member, so it can be resolved into its component EFX towards negative y-axis, x-axis, and EFY towards the negative y-axis. So there is only one unknown in vertical direction. So I'm going to apply sigma Fy equal to 0 first. And for sigma Fy equal to 0, EFY is negative. Then 2L is acting vertically upward, positive, and load is acting downward, so that is negative. So after simplifying, EFY is equal to 1.5L and EFY is EF sine 45. So then EF is calculated as plus root 3 over 2L. Next, by applying sigma Fx equal to 0, so DE is negative towards negative x-axis, EFX is negative, and then EX is also negative. All are negative. So equation can be rewritten as dE is equal to minus EFX minus 2L. So EF is already calculated. So EFX is equal to EF cosine 45. And then after simplification, dE is minus 3.5L. Because answer is negative, so dE is in compression. So both AB and DE are equal in magnitude and have the same sense. Although this truss is geometrically symmetrical, loading is also symmetrical, but supports are not symmetrical. But if the angles are same or reactions are same, so then the mirror image members, so they have same member force with the same sense. So and next I need to calculate CG. So for that CG, one way is like after solving A, I need to go H and then need to solve B, and then after solving B, I can solve C. But there is a rule here about this type of joint. So the rule is three-member joint with load parallel to a member. So it is joint C is a three-member joint and a load is parallel to member CG. In a three-member joint, when two members are collinear, so BC and CD are collinear, and a joint load act parallel to non-collinear member. So non-collinear member is CG, and a joint load is acting parallel to it. So non-collinear members carries a force equal in magnitude to the load. So then in CD, so CD member force is equal to the applied load but in opposite sense, while the two collinear member carry equal and opposite forces. So two collinear member uh, con- uh, they carry equal and opposite forces. So I'm going to draw joint C, and then on joint C I'm going to apply the rule. So free body diagram of joint C is being plotted here. So only required member force is CG. So I have assumed that is intention. So BC and CD are not required. I'll simply apply sigma Fy equal to 0. Otherwise, using the rule is so that CG must balance that load, and because load is acting vertically downward, so CG must balance it and CG be in upward, so then CG must be in compression. So now applying sigma Fy equal to 0, so CG and both acting vertically downward, so negative, and CG is minus L. So as CG is minus L, so negative answer shows that CG is in compression. So now at joint C, so that is the answer CG is calculated now. So now three member forces A, B, D, E and CG are calculated. So A, B and D, E are 7L over 2, which is 3.5L in compression. So they are calculated here as AB 3.5L in compression, DE 3.5L in compression, and then CG is L in compression. So that is being calculated. So that is a complete solution of this problem. Thank you very much for watching.